Hello friends, this is Jim with Science Talk. I have a very interesting article to share with you. And it has to deal with changes in the Earth's crust that can be linked to climate change. Now you've heard me make allusions to this in previous videos, and I'm in preparation of a video now that tries to ascertain the history of Earth's global temperatures for its entire existence. And there's a very interesting thing to note in the graphs that I'm looking at, namely that we see a major downward trend in temperature, and that's because Antarctica started moving to its current location. Once Antarctica took up its position, its current position, planet cooled down drastically. In fact, Antarctica is called the planet's refrigerator. But so that's like coming events in a future video. So there's some researchers who think there may be an ancient link between catastrophic climate change and the forces that build mountains or shifts in the Earth's crust. Movements of the Earth's crust may mean that global warming driven by greenhouse gases from human activity may not be the only threat to life as humans know it and human civilization that the world faces. About 700 million years ago, global temperatures fell so low that glaciers may have reached the equator, referred to as the snowball Earth or the slush Earth. I did a video on that some time ago. Snowball Earth may have all but extinguished life on the planet, but the only life at the time was microbial and was dispersed in the ocean. Okay, 700 million years ago. This is before the Cambrian explosion, which is about some 525 million years ago, give or take. The planet survived, of course. Volcanic eruptions may have put soot onto the ice, which darkens the ice. It allows absorption of sunlight energy, and volcanoes might have pumped more CO2 and steam into the atmosphere, allowing the planet to warm up again. Now, it is difficult to pinpoint CO2 levels in the past. We can go back several million years because we have corroborating evidence from a number of sources that all indicate the same results, the same levels of CO2. So we can say with very small error margins that the levels are as we indicate in the data. As you start going back into 65, 70, 100, 200 million years ago and further, it gets more and more difficult. Yes, we have means to get an estimate on what the temperature might have been, and there are ways to test for that. Not precise, but it's certainly more precise than trying to pinpoint what a CO2 level was back then. It's just difficult. The errors are just way too large. So the values are compelling, the values are suggestive, but they're not accurate, they're not, what I'm trying to say here, has not been validated as being, they've not been verified, they have not been shown as, okay, we've got a really small error here, so we can be pretty confident that the levels were right in this vicinity, as opposed to being from one end to the other end. So I have a video on that coming out in a week or two or so. So, two Texan scientists now say the frozen plain in what geologists call the Neoproterozoic era may have been precipitated at the start by the first dramatic movements in the Earth's crust or lithosphere, known as plate tectonics. That is, shifts in climate and shifts in the Earth's crust could be linked. But of course, because the positioning of the continents will determine where the oceans are, will determine the current and circulatory patterns of the ocean, which will in turn determine how heat is distributed over the planet. So this is a perfectly valid hypothesis and makes perfect sense. Hey, Dr. Robert Stern is a geoscientist at the University of Texas at Dallas, said, Earth is the only body in our solar system known to currently have plate tectonics, where the lithosphere is fragmented like puzzle pieces that move independently. Right? Professor Stern and Nathan Miller, his colleague at University of Texas Austin, report in the journal Terra Nova that there could be at least 22 ways in which the movement of tectonic plates could have delivered a calamitous drop in planetary temperatures, and they propose that until about 700 or 800 million years ago, the planet's crust was rigid. Only in the Neoproterozoic did the tectonic plates start moving, grinding away and building mountains and so on, creating eruptions and setting up weather systems that accelerated erosion, and then the erosion could help draw down CO2 levels into rock carbonates. And if you draw down the CO2, and there's no fossil fuel yet to be burning, we can cool the planet down. Now, keep in mind, this research is tentative. Okay? The authors are offering a hypothesis, and it's to be challenged, and they welcome it. Go challenge away. This is what science is about. Provide data that supports our contention. Provide data that refutes it. Let's have at it. Okay. So it's a hypothesis that they want to be challenged rather than a theory to be confirmed. But this kind of research is important if you want to have a fundamental understanding of the subtleties of the present climate. So if we can get a handle on what happened in the past and why, then we can then establish the principle that can control today's climate. The Texas study's most radical proposal is a new date for the commencement of tectonic activity relatively late in the planet's history. The idea that Earth was all but covered with ice has been confirmed in various ways. What is new is the suggestion that the movements of the Earth's surface might have triggered a climate reaction, convulsion, what have you. In the present day, climate is in the news because humans are changing it. Right? We're putting the CO2 into the atmosphere. We're putting the methane up there. This is Professor Stern. Imagine a time when Earth didn't have plate tectonics and it then evolved to have plate tectonics. That would have been a major shift in the Earth's operating system and would have had a huge effect on climate too. So I just find this to be really fascinating. And it makes perfect sense because, as I said before, the positioning of the continents will determine oceanic flow, which will then determine how the currents, how the water is heated, how the heat is distributed around the planet. It will determine air mass movements and so forth. Well, it's coupled together, the atmosphere and the ocean. So that makes perfect sense. And as I said, when you look at the data, the temperature data, you can start seeing when it notably starts cooling down. That's only because of Antarctica. If Antarctica were not where it is today and we were doing what we were doing, human civilization probably would have snuffed itself out by now, in all seriousness. The temperature spike would have been dramatically much more. So, as I said, I'm working on some videos that will talk about this in a little more detail. So stay tuned, and we'll talk soon. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos, please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.